Sarete seduti, immagino qua. Cioè io vi chiamo, vi chiamo, vi sedete lì e poi...
Okay. Buongiorno, good morning, everyone. If you could please take a seat with your coffee, we'll start the morning. Aside from the people here in the room, we actually are streaming live on our YouTube channel, so I think it's a good form not to get them to wait too much. Okay? So please take a seat so that we can start the day and the people will join us. So I'll leave the floor to Mr. Matteo Beccuti, which is the Chief Executive Officer of Environment Park.
Welcome everybody in Environment Park for this day dedicated to hydrogen. As many as you know, Environment Park is a technological park working for environment and innovation. We are an open campus offering laboratories, infrastructures, and hosting demonstration of innovative solutions. Our mission is to be a reference point for public and private actors engaged in innovation towards sustainability and at national and international level. We work on different innovation areas such as green chemistry, advanced surface treatments, energy efficiency, and hydrogen. Regarding hydrogen, we represent the local supply chain, and we work with the regional authorities of territorial strategies for the implementation of the hydrogen economy. Hydrogen represents a key solution to ensure sustainable energy supply towards the goal of European climate neutrality. For these reasons, this year, Environment Park dedicates its Hydrogen Day to the sustainability of the hydrogen value chain. Today, we will explore hydrogen production and storage, off-taking, design and manufacturing of hydrogen devices, and the end-of-life management under the lens of sustainability. Thank you very much for being here, and I leave the floor to Ilaria for the starting of proceedings.
Thank you very much, Matteo. So good morning. I'm Ilaria Schiavi. I am the coordinator of Project Best for I. Best for I is sustainable solutions for recycling of end-of-life hydrogen technologies. Is a project funded by the fuel cell and hydrogen undertaking now, the Clean Hydrogen Partnership, and is the main sponsor of this project, of this day. So today we will be exploring sustainability along the the value chain of the fuel cell and hydrogen technologies. We have quite a lot of speakers today and presentation to go through and discussion. You see around the room and also on the screen there the main key for your day. This is the QR code which will bring you to the agenda for the day, will bring you to the Slido contact. This is important because this is a way for us to interact with the public here and on YouTube. Also, you will have the opportunity to see the Swapcard facility. So the Swapcard facility we have signed you up to for enabling a little bit of business networking. So you are already signed up the moment you signed up to this event. So please open the app that you will find at the QR code. You will find the list of the people already here. You will be able to organize with them some informal meetings. So if networking during lunch is not enough, we actually have a room available for you on the left by exiting this room where you can meet at ease and discuss with the people you would like to meet today. So please make sure that you check your Swapcard from time to time because you might have some requests for meeting. So this is it. I think that we can now start the proceedings. I will invite on the floor the first moderator of the day, so Professor Massimo Santarelli. Professor Massimo Santarelli is Professor in Thermodynamics and Heat Transfer at the Department of Energy for the Politecnico of Turin. He's author of nearly 300 papers in international journals and conferences. His research activities is mainly linked to electrochemical and thermochemical system aspects as applied to energy, so fuel cells, electrolyzers, thermocatalytic technologies, energy storage, hydrogen global management, and CO2 global management. He's the coordinator of hydrogen activities for the Polytechnic of Turin, and is also the scientific coordinator of the CO2 Circle laboratory, which is a shared facility here in MV Park between Polytechnic of Torino and Italian Institute of Technologies. I'll leave you the floor so you can call the panelists and start the discussion. Thank you.
Okay, thank you, Ilaria, and so thank you for inviting me to coordinate this initial session. Yeah, I already make my presentation. So what I can do now is to introduce the speaker. It's correct. So I can invite three relevant speakers for the first session. In my list there is first Professor Paola Rizzi. So thank you for joining the stage. So Paola Rizzi she's a professor of material science and technology at the University of Torino, a PhD in chemistry, full professor in material science, and teaching metallic materials and material science in chemistry courses. In terms of research, which is the important topic today, is the focusing on development of advanced material for hydrogen storage. So the focus is more on storage with material, not in form of gas, and design of integrated system, including the storage. Also, it works more fundamentally on production of amorphous and metastable metallic material for advanced application, and synthesis of property of nanoporous material. So, some research more fundamental, but going to application. Then maybe you can sit. I think we join all together, and then you can have a presentation. The second speaker, I think, the second speaker is from a big company. So Patrick Scialabra from De Nora, Italy. So thank you, Patrick. Patrick has a PhD in chemical engineering from Politecnico di Milan, and now he's working after a period as a consultant. And now he's working in the innovation sector of De Nora, that probably most of the people here in the room know very well. De Nora is a historical company working on electrochemical system, basically electrode. Now he's developing important product in the domain of electrolysis, also big size element, but he will explain better than me in his presentation. The third speaker is Carlo Luetto. Thank you, Carlo, for joining. So he's the CEO of Tecnodelta, which is a company here in Torino. So Carlo is very famous in the domain of hydrogen. He's more than 30 years working on innovation in the domain of technologies, including hydrogen. So I'm going to read because it's long. He founded the company, the Tecnodelta, where he's the CEO at the moment. He's involved in research project, so also making some research activity, innovation activity since 2007. And now he's working, for what I know, we work a lot together in the lab. So most of the problems that we have in the lab are solved by Carlo, I can say. But also he's developing product, mostly in the domain of energy storage, but Carlo can tell better than me, to be more precise. So the panel, I think, is very interesting. One from the research area, but with application, which is Professor Rizzi. Two companies, one very big, De Nora, and one very high innovation in terms of technological level, which is Tecnodelta. I think that now the floor go to the speaker. I think we start from Paola Rizzi. So we have a short presentation of the three speakers and the activity that they do, and then we will start with some questions. Thank you, Paola. If you want, the floor is yours.
Okay, so thank you very much for the presentation. So I will mainly talk about storage of hydrogen.
Sorry, I'm just waiting for the... So we cannot see the presentation.
Okay, so first of all, I want to talk about hydrogen storage. First, starting from what we are able to do at the University of Torino in the Department of Chemistry. And definitely we are able to make both experimental and ab initio studies. So from the experimental point of view, what we did, what we are doing is to make the synthesis and the characterization of the materials from the structural and microstructural point of view. So let me just put this. Okay. So from structural and microstructural point of view, but we can also use spectroscopy, and then we can determine the sorption properties of the material in order to understand which are, for example, the temperature and pressure of equilibrium for the hydrogen, but also which is the amount of hydrogen that can be stored in the different materials that we are synthesizing. But then we can also make ab initio studies, and in this case, so we can bring the information taken from the calculation for the modeling, and get finally information from the thermodynamic and kinetic parameter of the system. That could be very important because of the information related to activation energies, driving forces, and phase diagram. But then another important point is the calculation of the environmental impacts of products or processes. This is nowadays very important when you are building up a new prototype, for example, in order to get if the prototype that you are proposing is really convenient for the environment. And in that case, we are doing life cycle analysis assessment. And so our main research activities is related to metal hydrides and complex hydrides. And now I will show you a few projects that we did on this subject, starting from this project SSH2S. Here you can list the whole list of the partners, and as you can see here, there is Technodelta. So I'm stressing this point because Carlo Luetto is one of our partners, so he joined us in many of the projects. So, we are involved mainly in the study of the material, and Carlo Luetto is mainly involved on the design of the system, of the integrated system. So we are studying the problem from the two different points of view. So in this case, for this project, the idea was to produce for this eco daily vehicle an integrated system in which there was a tank with metal hydrides that was integrated with a fuel cell. And in this case, the tank that we designed was a combination of two materials, and the materials are these. So the tank was a mixture of a metal and a complex hydrides. Here you can see the details. In that case, we also we performed the life cycle analysis of the prototype, and here is an example of what we got. Let's say that mainly the idea is to check if the prototype is environmentally friendly, and in that case, in fact, we found that the proposed tank has an environmental impact that is similar to simple tanks that are nowadays used for storing the hydrogen in the gas state. Another example, always in connection with Technodelta, is the production of a system, an integrated system with a fuel cell and a tank. In that case, the fuel cell was 1 kilowatt, and this is the prototype you can see here, and this is the tank. So what we did was the design of the metal hydride, and in particular what we did is to start from a very well-known metal hydride that is lanthanum nickel 5, and we adapt the composition to the requirement of the integrated system. In that case, the requirement was to have desorption temperature that was around 60, 50, 60 degrees. So we adapted the composition adding aluminum in order to tailor the temperature of equilibrium and pressure of equilibrium. Then there is the iCare project that is just finished last month, and in that case the process is a bit complicated, but let's say that the main point is that there was an integration of metal hydride tank with a PCM tank. PCM means phase change material. So in that case, we were able to recover the heat, to store the heat produced during the desorption of the metal hydride, and to use it for increasing the temperature, and so enabling the desorption of the hydrogen. In that case, we produce a system, a prototype, that is this one, in which it was possible to store 40 kilo of hydrogen. So also in that case, Technodelta was there with us. Then another example is the compression of hydrogen, because definitely if we want to go to a real use of the hydrogen, we have also to think about the compression of the hydrogen in a refueling station, because then we can need the hydrogen in the gas form at 700 bar in the tank. So in order to make this compression, there are a commercial compressor, but it is possible also to use metal hydrides for enabling the compression of the hydrogen. In that case, you do not need the moving parts, you just need to increase the temperature, and so you get the hydrogen that is compressed. So somehow you can use a metal hydride that is designed to have a very high pressure of equilibrium at around 100 degrees Celsius. In that case, you just have to store the hydrogen and then to release it at a very high pressure. And you will have a compression without using anything else, just the temperature that is changing. This is the prototype that we made also in that case with Technodelta, and these are the alloys that we used in that case. So the idea is to continue in that direction. We are studying different alloys in order to increase the pressure of equilibrium, and so to get an efficient compressor. And these are the tanks that were designed from Technodelta. So I want just to conclude by showing you my group, and this is the list of the people that are working in my group in the topic of the hydrogen storage in the solid state. Thank you.
Okay, thank you, Paola. It's very relevant. I know very well the activity at the European level, and it's good that this activity of research has now generated some application, which is at the end what we expect from research. In this sense, I think that it's interesting probably to have the presentation now of Carlo Luetto, which is well connected to the presentation of Paola, because we are working together in form of the application of this type of research. Okay, so Carlo, yeah.
So, good morning. Thank you to invite me to this event. My name is Carlo Luetto. I'm the CEO of the Technodelta. I will try to.
I lost the mouse. Wait a second. I lost the mouse. Here you go.
Okay, so you probably understand that we are working in research activities. The company is a very small company. We were born in 1997. We are located in Chivasso. It is a city close to Torino. And we normally, our activity about the hydrogen sectors, we work in a special plant, in gas systems, in safety device, and also in hydrogen solution, not only related to the storage. We normally make systems according to the customer's needs, so we don't have any standard products, but all the products that we develop are based on the needs of the customers. Just to give you an idea of the sectors in which are working, I put some pictures that is more easy to explain. So here there is some, for example, testing plane for the aeronautical components. We normally work with gas as a fluid. So in this case we were working with oxygen. It was a very big plant for the testing of the pairing with the satellite. Another one in the middle is a purification unit for CO2 used for the ExoMars mission, and it was a system to purify at ppb level the CO2 in order to clean all the components of the station. The other one is a system to mix nitrogen with moisture in order to create a moist nitrogen. Another one there is a system to recover the radioactive gas on the outlet of the experiment in order to store for a certain amount of months and then to release to the atmosphere. And then on the other side we have a low temperature protection device. This is the only product we have as a standard product for always for the use of gases. Here there's a list. Most of these projects were in cooperation with the University of Torino. Just to is the list of the project we did, and here the result of the project. All this project we put our effort in engineering the tank, the vessel, to contain the metal hydride. We decided to start on these topics because the storage of hydrogen normally is with a compressed gas or a liquid phase, and this is, let's say, a technology in which there are not so many applications. So we decided to explore this field. We started in the 2007 to make the first experiments, and it was the one on the top. It was his vision, where we explored the technologies and we built the first prototype tank. Then, after that, we learned a lot of things, so we decided to proceed with our experience, working with regional and also in European projects. Because we learned a lot, in 2021 we decided to have a new adventures. So we make a startup that is the name is Metaidor, and is a startup dedicated to the building manufacturing of system to store hydrogen in metal hydride. Of course, is our is what we know better. So why we decide to store hydrogen in metal hydride? Because today we have available on the market electrolyzer that are working with a high purity hydrogen and deliver hydrogen at 30 bar. That is a pressure that is very good for the metal hydride systems. So in this case you can couple directly the production of the hydrogen with the storage without having any compression. It is another value to the solution. We work at low pressure, so maximum pressure is 30 bar. We work also at low temperatures because metal hydride needs some temperatures in order to release hydrogen. But in this case we select an alloy to work around the 40 degrees these maximum temperatures. So it's the temperatures that is normally available in the process. Then we have also an high volume density of the system, and it's also important because you can store the metal right inside of some industrial site, and you can have also low distance because of the low pressure that you have inside of the storage systems. So all these things give us the effort, so the possibility to make these adventures. You can see there an image of our solution. This is just to give you an idea of what is the volume hydrogen density of the system. I put here a module that is our standard module, that is S240, and you can see that we can compare our system with the compressed hydrogen gas till more or less 350 bar. So the same amount of gas that you can contain in a cylinder of 350 bar, you can contain at 30 bar low pressure in our system. I put here just to give you an idea of what is our system. We develop a system that is made by different modules. Inside of this system that is like a tower, we have many modules. You can decide to add module in function of how many kilos of hydrogen you want to store inside of the systems. In this case, as a module of 7.5 kilo, you have store energy for 240 kilowatt hour, so it's quite a good numbers. Charging pressure you can have from 20 to 35 in function of the temperatures that you have during the charging phase. Delivery is more or less 40 degrees. The design of this system is very performant because you can have 4.5 kilos per hour of delivery flow rate, and in this case you have we did a lot of tests, and then you have the flow rate that is stable till 95% of the capacity of the module. Dimension of this module, just to give you the idea, is 1.6 meters per 300 centimeters per 1 meter, so quite small dimensions. The target, the customers and the market we are dealing with, we can propose this system in many sectors. The sector that we cannot use these technologies is the automotive, because we are dealing with metal hydride, and of course the weight is an issue about these technologies. But we can use, for example, in renewable energy resources as storing the energy. We can use in refueling station as the low pressure buffer, and also in a micro off-grid community, so increasing the amount of hydrogen you can use in these sectors. We did a lot of experience in marine application, because it's interesting technologies for this solution. Because in the marine application, the weight is not an issue, because the weight in the ship is used as to balance the center of the ship. So we did already 3 or 4 projects in this field, and it's really interesting. And then, of course, all the things, the integrators where there's the needs to store hydrogen. Okay, this is the last. This is an idea of a typical system for our application. Gliders, energy comes from solar panels or winds. We can store, as you can see there, we can put more than one module in order to increase the capacity of the system. And then you can use the fuel cell So that was it. Thank you.
Okay, thank you, Carlo. Indeed, a very good example of how the research can be can generate innovation and real product, which is, I mean, paradigmatic in this domain of, in this case, in the domain of hydrogen. I find interesting the application that you consider about shipyard, so the maritime application, which is in some way exploding in the sense is becoming more and more important in this domain of hydrogen. Probably not with hydrogen in some cases. Big ship probably will be more related with methanol and ammonia, which is a way in which hydrogen can be transformed. Just a short comment. Last week I was in Reykjavik for a big conference in Arctic of Arctic activities, and they means Scandinavia, Canada, Greenland, Iceland, Alaska, that big part of the future in terms of what they can do in terms of innovation can be related to the domain of hydrogen. They can produce big amount of hydrogen thanks to the big wind that we have, wind energy, and they consider that can be possibility for them to export this hydrogen to other countries that can be importer. How to export? Most will be through shipment. So ship stored in this way or in form of a liquid that will be both a storage of hydrogen and a fuel for the ship. Ammonia, methanol was really very discussed, and not discussed by only, let's say, researcher, professor. I am a professor, but from ministry that were participating to the conference. So ministry from Denmark, Canada, and Norway and Scotland. Okay, so apart this, we go to the third speaker, which is Patrick Schilabra, which is representing De Nora, so a big company. We are discussing a lot with them because it's one, I think, of the most important activity now in Italy at the industrial level in the domain of hydrogen, and so we will know some more now. Thank you, Patrick.
Thank you again, Massimo, for a kind introduction. It's really a pleasure to be here, and I would like to start briefly this presentation just to give a more context about De Nora. Sorry, let's put. Okay, perfect, great, thank you. Now, I would say that I would like to spend this preliminary introduction by giving more context about our company, De Nora, since it's a really important anniversary for us. It's our first 100 year of history, and that are, let's say, paved with strong expertise in electrochemistry that bring us to what we are doing now, especially in the energy transition field. So just to give you more information about De Nora, it's an Italian multinational company. It's the largest supplier of high-performing coating and electrodes for several industrial applications. For example, chloralkali production, electrowinning, and also water treatment. But in the last year, we decided to be more focused on the energy transition and manufacture of component system for hydrogen production. That's why I'm here to talk in this panel. And last year we have been listed to the Borsa Italiana in the Euronext Milan Stock Exchange in order to, let's say, boost furthermore our involvement in the energy transition field. Here are some figures about our company. It's, as I said, it's a multinational company that has a global presence, and we are doing that with 25 facilities around the world in North American, European, and also Asia, in order to be able to be in proximity with our clients and their needs. We reached in the end of 2022 over 800 million of revenues, and as I said, we have a strong background in electrochemistry, and we value our innovation and research activities as demonstrated by all the patents that we filed around the world. We have over 200 patent families. We encounter also a very strong organic growth in personal. These are, let's say, quite old number. We passed in the 2023 over 2,000 people. So I think it's a manifestation of how our business for the energy transition is growing. As matching of the current demand globally. And I will go very briefly. That is just to, let's say, to highlight how how De Nora is facing the challenges related to the energy transition. As I mentioned, this is just a more, let's say, young business, let's say, sector for us, but stands on the shoulder of our expertise, since we have a really, really strong background of as a pioneer in the electrochemistry and as a coating electrode manufacturer. As you can see, in the first year, we our founder, Lorenzo De Nora, patented a coating that is labeled as DSA, which was an anode with really, really strong performances. That, of course, it was improved and the family was expanded, but they are still employed in our coating that are also, we will see later, also operated in our hydrogen generation system. As you can see, especially in the past year, we decided to boost the energy transition. We mainly work in 3 fields. Of course, we focus on the energy transition, but as I said, we have several products that cover the needs for our client related to mainly for anode, cathodes, and coating, and for different applications. But just to focus on the energy transition up to date, can we go directly to the next slide? We have different products to serve different clients' needs based on where they are located in the value chain of the hydrogen production. At the moment in the market, we have electrodes for alkali water electrolysis, which is the main technology that we tackle among the one that are on the market. And as I said, they are highly performance based on the proprietary coating DSA that I was mentioning before. But we are also involved in the manufacturing of cell, also for alkaline water electrolysis, mainly for our joint venture with ThyssenKrupp Nucera, where we manufacture electrodes and cell for this joint venture, for building, for manufacturing, in particular, electrolyzer module of 20 megawatt. And we are also involved in the manufacture of gas diffusion electrode for fuel cell, in particular high temperature PEM fuel cell. But it's not limited to what we currently see here that is already on the market. We have under development other products, almost ready for the market, like a small size alkaline water electrodes electrolyzer, which is a complete system, a containerized solution for of small scale, around 1 to 10 megawatt. There are say several sizes for that, and which is almost ready for the market. But we are also involved in the other research activity. So I talk about the most mature technology with the alkaline water electrolysis, but we are also interested in an ion exchange membrane electrolysis. And we have several R&D projects and also funded at the European level, but also with other companies. And we are also interested in the transport and storage of hydrogen more through liquid organic hydrogen carrier, so also in order to exploit our expertise in electrochemistry and also to CO2 valorization. These are more at lower TRL product, but we are strongly involved on that. And just to give you as a last slide, but of course during the panel we can also discuss regarding our involvement in other projects, but I would like also to give you an overview of our current capacity, which we up to date, or at least at the end of 2022, so at the end of the past year, we had a capacity production of 2 gigawatt, and we strongly believe in the future expansion of this sector for the energy transition. So we have a current plan to increase furthermore our production capacity for coating capacity, but also for electrode production to reach in 2025 6 gigawatt of capacity production. As you can see, most of them that are mentioned here, like for the US, Germany, Rodenbach in particular, but also in China and Japan, are a further expansion of our facility, try to improving furthermore the capacity production and increasing the level of automation what we are producing now. And in particular, regarding what is happening, at least here in Italy, in the bottom left corner, it is mentioned our future gigafactory that will be built in the next year. We already started by purchasing the land and started with the first activity, and this is a part of an IPCI project, so an important project of common European interest. We have been awarded last year, and we are really proud to boost the hydrogen space, contributing with a gigafactory that can reach, of course, as the name mentioned, more than 1 gigawatt of production for several electrode components and electrolysis system, as the one that I mentioned before in my scheme. So I think that's everything. For give you a context, we can discuss deeply during the panel discussion. Thank you very much.
Okay, thank you, Patrick. Impressive. These are a stronger reality. Starting from Italy, but expanding in a global level, with big ambition, which is what is needed. So now we can go to the part of the panel. Is the more difficult part for the chairman, which is me. I know that we have to use a slide or connection in order to make question, but before question we have to launch a poll. Is correct? So I need an help. Yeah. Something will appear. Yeah.
Yes.
Okay, so basically we have an interactive procedure. So this event is mostly oriented to companies. So we think, so we consider that there were companies interested to attend. But of course, everybody is invited to participate. So we have considered a poll, an active poll, that you can participate. People here in the room, but also the people that are connected remotely. We launched the poll now, so you have time to make your indication, and then we will discuss the main indication later. So the poll is the question is, as you see, which step of the hydrogen value chain are you more interested in? Because we know and then we'll go back on this. The hydrogen topic is a topic related to a value chain. Of course, it has to be produced, as we know. It has to be transported, stored in many cases. And then there is the big aspect of the offtake. So what to do with this hydrogen and which sector. Can be chemical industry, can be transportation sector, can be storage. So there are several applications in terms of offtake. So the first point is which step of the hydrogen value chain are you more interested in, where you think that as a company you can have an interesting evolution of your future activity in which of this domain. And then there is a second part, I think, where I go down, simply. No. Yeah, because there is some, which, we can do it later. Okay. So we go step by step. This is the first step of the poll. Okay, so said we can go to a panel discussion. Okay, so as you connected to the discussion about the value chain, is a value chain, as we said just now, Maybe you notice that in the panel there are colleagues that are working on basically two steps of the value chain. They work some of them in many applications, but mostly at the moment today on two steps of the value chain, which is the production, especially the NORA, and the storage, especially Tecnodelta and University of Torino. So probably there is a hole or a vacancy in the panel. So the point is, of course, everybody knows that there are probably more and more companies and, of course, researchers and so on that are ready to produce hydrogen, green hydrogen, or in several ways, electrolysis or other ways, mostly electrolysis. There are companies that are willing maybe to store and transport, but all this has a sense only if there is an off-take, which is significant. We know this. So the important point is the off-take. So companies that really need this commodity, this gas, or in other form, but basically it's a gas, for energy need, for chemical need, for transportation need, and for other type of application that we can discuss also today. So my first question is, in your vision, you are developing activity on this aspect because you think that there will be an off-take, I'm sure, of course. In your type of activity, what do you think will be the position of your company? So which type of application you will target? It can be the energy sector, the chemical sector, the transportation sector. Where do you think that will be the best market opportunity for your type of product? And this is a global question because you can have your idea of how the hydrogen sector is developing. And second point of the debate is how do you think is some policy decision or some instrument that can be decided in order to support what we are doing in terms of developing new technology and new product, and to support a bigger offtake of this technology by the market. So where you are, where you will see your main activity in terms of sector of application, and what you think is needed in order to support this application in the future. Okay, so it's a panel, so you can use the microphone there, or you can decide freely. Yeah.
Okay, so I will try to bring the point of view of, as you see, of the NORA, which is mostly related to the production side of the value chain. And okay, can you hear me? And as you saw, we are manufacturer of component and system. So we do not directly, we are not directly involved in the production of hydrogen, but I can bring you our, let's say, experience in interacting on with original equipment manufacturers, so the electrolyzer manufacturer, and also with the EPC company that they try to operate in the field the electrolyzer, or at least electrolyzer they contain our components. So I think that the answer can be, at least for the off-taking, the sector that can off-take the hydrogen can be at least twofold for our side. One is for the really, let's say, big plants, especially the one we are involved with our joint venture company, ThyssenKrupp Nucera. Mostly are not, let's say, EU-centered, but because they are located in a region where the renewable energy sources are really cheap. Like I bring the example of the project NEOM in Saudi Arabia, where they are started the manufacture of this plant, which will bring in the field over 2 gigawatt of electrolyzer for the synthesis of green ammonia for their transportation. That's one, for sure, one of the main fields. But there are also other projects like in Brazil, where will provide also around 70 megawatt of electrolyzer for the synthesis of green fertilizer. So the hydrogen as a feedstock for all the, let's say, chemical pathway that need hydrogen as let's say, as a commodity for the synthesis, I think will benefit of green hydrogen for sure. But there are also other sectors that can let's say, that benefit from green hydrogen, and I would say that are all the sectors that they usually be labeled as hard-to-abate, so they cannot be electrified. I'll bring another example, also related to a project that we secured via the joint venture, which is a project in Sweden of around 700 megawatt for providing green hydrogen for a steel manufacturer. So also in this case, I think the steel making for all the industrial application where steel making is involved is one of the main points for the decarbonization, I would say. But also at the Italian level, where maybe this is not the main focus, they can benefit, especially for a decentralized production of green hydrogen, maybe via electrolyzer with a smaller size. That can be also of interest, especially based on our, let's say, what is in place regarding the business sector that can be at higher level of the hydrogen readiness. I will say we had a lot of interaction with glass company that can use it for their burner, so similar to the so the steel making process, but also for the ceramics. We have in Italy a lot of different districts that can exploit green hydrogen, but they are not only related to the manufacturing side, also mobility. I would say especially heavy duty transportation for train, but also multi-main application can be also affected by the utilization of green hydrogen, for sure. And regarding the second part of your question, so just to summarize, I would say that hydrogen as a feedstock for several pathways, so for chemicals and maybe also for in the e-fuel, for example, and all the applications that need to substitute all the sectors that are, let's say, hard-to-abate sectors, so they cannot be electrified. They need hydrogen for sure, like steel making, glass, and ceramics. Just a few examples of that. And in order to, let's say, boost the demand of hydrogen, with all the instruments that can be needed for that, I think that the European Commission is doing a really good job with implementing the IPCEI project in order to create and avoid a market failure for the hydrogen, thanks to the several waves that have been awarded with, and they are still under, let's say, evaluation right now for the IPCEI project. So for starting from the technology at the base, so for electrolyzer, fuel cell, in order to, let's say, minimize the capex, and also try to increase their technology readiness, maybe try boosting their performances so they can be affected also at the OPEX level, so for diminishing both the CAPEX OPEX can, let's say, effect for an off-taker who will produce the hydrogen, the levelized cost of hydrogen, so they can be try to really pushing on both sides in order to make it more viable. And also try to create a whole hydrogen economy, whole hydrogen space, based not only on the technology at the base, but also try to boosting the infrastructure, the mobility sector, and their application. This, I think, the IPCEI is really doing a really great job. And in the future, maybe at both national and European level, I hope that more incentives at OPEX level will further boost the demand for hydrogen.
Yeah, thank you. I mean, really a lot of input, I think, from Patrick. Just a very short comment, and then of course I give the microphone to the speaker. Is what is also observing the situation. Probably the biggest of take will be apparently also Patrick confirmed from the chemical and the industry sector. So sector that already was using hydrogen. so the chemical sector, and some sector that are interested to use hydrogen for very practical reason, also related to the carbon emission, which is the steel. So big offtake probably we will expect from this type of sector. And then the sector of mobility is what I also observe going around the world in this period. Yeah, also a lot of indication from you are also interesting for me, in order also for a PhD that we have we are doing in terms of which type of sector is interesting. You give a lot of indication about this. Anyway, we go now to Paola and Carlo with the same. Yeah, you can use the microphone. I think only one. Oh yeah. Oh.
Thank you. I will continue your comment. Well, what could be useful for increasing the hydrogen use is also to go for cheaper material, for example, in the storage sector. I know more about the storage, but in fact what is a bit complicated at the moment for the storage point of view in the solid state is that the materials that are used for the storage, so for example the alloys that are used in this moment have quite high costs. So for example, if you want to store 10 kilo of hydrogen, you have to use 1 ton of metal. So it's quite a big amount. So if the metal is expensive, then definitely the storage part will become expensive. So what we are working on now in the at the research level, so at the basic level, is to try to reduce the cost of the alloy, and we are working in 2 directions. So the first one is to go for cheap material. So for example, to avoid the critical raw material, and also for example the rare earth that are quite expensive, that produce just mainly in China. And so we want to move to titanium iron that is a bit less expensive, and also we are working on the recycling. So the idea is to work on scrap material, for example, or on commercial materials that can be used to produce storage alloys. This is all in the line of reducing the final cost of the alloy. So this is one comment on that point. And then if we are thinking about sector in which hydrogen can be used, so the marine sector that Luetto described before, it's quite an interesting sector, because in fact if we are thinking about storage in the solid state, it is very difficult to think about the storage in a car, for example, because then the car would be very heavy, so it's impossible. But if we think about a boat, definitely in that case we need the ballast. Okay. And so this definitely can be a metal hydride, and so we can somehow use this weight for making the storage of the material. And then another important sector is the refueling station, because also in that case, if we want to make if we want to produce car that use hydrogen, definitely we need the refueling station. And in that case, so we need an efficient storage part, and then we also need a very efficient compression part of the hydrogen, because in the car we will need hydrogen in tanks at 700 bars. So definitely we have to bring the hydrogen to this very high pressure, so we need to reduce also the cost of the compression. So the idea of producing compression compressors with the use of metal hydride is always in the way of reducing the cost of the compression, and reducing also the cost for the environment for in the compression state. So that could be also a good point to work on.
Yeah, I completely agree. Oh, sorry.
No. It's better if you talk. Yeah.
Completely agree with you about the cost of the materials. That is a point in which we are working together with them in order to reduce the cost of the alloys. Regarding all the application, I already put on my presentation possible application of our technologies. And I would like just to answer to the questions about how to boost our systems. What we found today is that there is a lack of regulation in these fields. That is really a point in which all the times we are going to approach a new project, we have to deal with fire departments or other institution, and frequently hydrogen is very known because it's very dangerous. So a lot of people used to put a lot of barrier in order to put hydrogen storage inside of some inside industrial application. So I think that if somebody can work on these topics, regulation, so to help also the people to decide about like fire departments, to help them to understand which are the difference between different kind of solution. Because today they know hydrogen as compressed hydrogen, and they compare always with this kind of application. And so I think that could be an help to develop also possible application in this field.
Yeah. So thank you, Paolo and Carlo, because you touched some points which are, in my view, relevant. One is the recycling, which is common to all the technology, new technology, let's say, from photovoltaic to batteries to fuel cells to metal hydride. So it's electrolyzer, of course. So the recycling of materials that are included in this technology it will be a topic of extremely high importance in the coming years. And actually, this workshop is also organized in the framework of a European project, which is Best4I, where I am also partner. We do this type of activity. So recycling material from exhaust technology to reproduce new technology from the exhaust. So this is a fundamental aspect. The second is the cost. If I talk to people working in the domain of hydrogen, cost and safety, I think that when they discover that it's possible to store hydrogen in another way, which is not to compress in 700 bar or 1000 bar, let's say, that they can do in another way, which is low pressure, very safe, intrinsically safe, like a metal hydride, so that solid state absorption, they discover a world that can solve a lot of their problems, especially, of course, in stationary application and in maybe maritime, not for car, for sure. So I think this is extremely high possibility of application related to the safety capability that they can guarantee. The cost is still maybe something that has to be, as usual, improved. So when this cost will become sufficiently interesting, I think that this type of storage for the stationary will be probably the first selection, with a rule different, maybe also compared to the compressed gas, because the safety is intrinsically assured compared to a high pressure vessel. So yeah, there's a lot of things open in this point. Okay, so we don't have so much time left. I think we have 7 minutes. So we have the result of the first poll. First poll, apparently we have the majority is in production activity, but is significant storage. And offtake is the lowest. In some way, it got to confirm what we discussed before. There is companies ready for production and storage, less ready for the offtake. So this is something that I think we have to work if we think that this is a good solution for our energy future, and not only energy, but in terms of sustainability. We can have the second poll, maybe, because time is very short. So the second poll is that you can participate if you want, which is which area is more vertically considered this. Which area are you working on? There is a bigger list, so low temperature and high temperature fuel cell, same low and high temperature electrolyzer. So basically, the fuel cell, which is a converter of hydrogen, the electrolyzer, which is a producer, so to produce it. Industrial application, so big topic, mobility application, and energy production. So the last three are basically which of type of offtake, in which offtake sector you are involved. Okay, this poll is open, but now we can go in the last 6 minutes, maybe to some question from the Slido to the speaker. He's already started, but we can comment a little later. So I go to the Slido to see. Okay. There is a first question which is related to the storage, which is the expected life of this type of storage system. So, duration and replication, replacement. Sorry.
But the life of storage system depends from the purity of the hydrogen that you are going to supply. The important thing is to give to this kind of storage pure hydrogen. 5.0 is maximum, is the standard quality of the hydrogen that you have to supply. The alloy that we are using today is a long life. The supplier give us some indication about 20,000 cycle charging, discharging, so quite a long life. The material itself can be also recycled. At the end of the story, if you have a system that is in contact with the air or moisture, you can recycle the material, put in the furnace and then melt again, and you produce again new material. So, but again, the number of cycle today, it's numbers that we receive from the supplier. We didn't test for such kind of numbers because it's quite high. So, but we are going to we hope that we can test.
Okay. Maybe Paola, will do
I can just add that we are also working on the, let's say, on the design of the material in order to improve the resistance to the impurities. That is the main problem when you are using an electrolyzer. So definitely, in order to reduce the poisoning of the material, in case it's life.
Okay, thank you. And there is a second question, which is, I think, open for all the speakers. Is related basically to what we discussed so far, the end of life problem, or recycling. So the point is, what could be the end of life management option of the device that you are designing, producing, and applying? So, what you see in terms of your product, in terms of recyclability and recovery after end of life, if you also have in mind this type of problems when you develop your technology, and which you consider the solution. Maybe Patrick, you can. Yeah,
sure. So let's say that it's in our expertise as a coating specialist to let's say to try to make it longer as possible the life of, in this case, electrolyzer, but also in the past for the chloralkali plants. We have a strong expertise also in recoating our electrodes in order to make it longer, and try to recycle the components that make the coating. So we plan also to doing that also for the electrolyzer when in the future it is needed. Of course, the time depends also from the operative condition or how you work with the electrolyzer, but especially for the atmospheric electrolyzer, for example, the design of the Scalum module, the one with the joint venture ThyssenKrupp Nucera, it is possible to, let's say, if it is needed to remove one cell without stopping the whole electrolyzer, in order to, in case, dismantle the cell, recycle the coating, and then recoating again and put it back, so it can, let's say, to prolong the life of the electrolyzer in that case.
I can talk about the powder, let's say, the metal hydride in particular, and in fact, well, it is a metal, it is in the powder form, so at the end of its life, the metal will be in the powder form, but it is possible to think about possible method for recycling it, and for, let's say, the main problem will be to remove the impurities and the oxidized part that are in the metal hydride, but definitely there are possibilities for making, for designing a recycling of the material.
Yeah, for the rest is a simple containers. That is, the tank is stainless steel. So stainless steel is a material that can be reused again. So at the end we have powder and stainless steel. So it's, let's say, it's completely recyclable.
Yeah, I think it's one of the advantages also of this type of proposal that you are developing in general, the possibility to recycle.
Yeah.
And was indeed interesting the way you are designed, Patrick, the mode in order to have a possibility to replace without stopping the operation. This is of course a very relevant way to design a technology in order to use it in the best way, also in terms of recyclability. Okay, so we are at 10:30, so at the end of this session. Only last comment, I see that the second part of the poll is apparently, is confirming what is the main trend now. So industrial application is probably the most important now in terms of offtake. Before, at the moment, compared to the mobility application, I think this will be what will train, will target the most big amount of offtake in the short, medium term. I think, for what I observe internationally, will be the industrial sector. So industrial that already use hydrogen. The hydrogen now will be not from fossil, from natural gas, but mostly from electrolysis. And then in the industry that have necessity to decarbonize, like the steel. Mobility application comes a little after this. And in terms of energy production, the energy production is probably the third sector of interest, for what I see. I don't know if you have a very last comment on the result of the poll, but just rapidly, because we are going to finish. If you have some, no, maybe not. Yeah, I think it's confirming a trend that is internationally everywhere in this way, I think. Okay, so we can stop this part of the initial session. I think we have a coffee break or something. Okay, so thank you for attending. Thank you especially to the three speakers. Thank you for coming and for sharing your experience. And yeah, now we can have a coffee and discuss even more if of interest. Thank you. Bye.
Okay, so you have coffee at the back there, and we'll see you in about 15 minutes.
Ma sei anche te, dai.
Ma l'idea era lanciarlo dopo le
Okay, everyone, so we will start again in about 5 minutes. So 10:55. Okay, it's time to start again. So please grab your coffees and take your seats. So now we will be opening panel 2. Panel 2 is on the end uses, state of the art of the most innovative and sustainable hydrogen devices. The panel will be moderated by Dr. Engineer Alessandra Cuneo, Innovation for Power Generation and Hydrogen Manager in RINA. Alessandra has a background in environmental engineering with a PhD in advanced energy systems. She works on European funded projects in power generation and hydrogen, renewable energy sources, innovation and technology transfer. She joined RINA in 2019 as project manager, and now, since this year, has been appointed as Innovation for Power Generation and Hydrogen Manager within the Energy Strategic Innovation Center. So she's responsible of a team that works on research and development, EU co-funded projects in the energy business unit. So Alessandra, thank you for joining us, and the floor is yours.
Thank you. Thank you, Ilaria, for the introduction, and it's a pleasure for me to moderate this second panel today, which will be related, as for the title, on the state of art of the most innovative and sustainable hydrogen devices. So the idea is to discuss together with you which are the current technologies for the hydrogen, which are the challenges of them, and specifically go through the two main type of fuel cells, so solid oxide fuel cell with a technology provider, so a company that work on that field, as well as from the proton exchange membrane fuel cell, together with combined with all the aspects related to the safety, which we know that when we talk with hydrogen, the safety is an important point, an important issue. So I'm glad to call on for this panel the first speaker, which is Sergi Pilopko, sorry for the pronunciation if it's not wrong, is the Director of Technologies at Alcogen. He holds a PhD in Chemistry and Material Science, and since 2012, Sergi is working in the renewable energy field and with the hydrogen technologies in particular, developing different concepts and prototypes for clean energy industry. Currently is the Director of Technology at Alcogen, and it is a solid oxide fuel cell and electrolyzer manufacturing company, leading the core component product development for the last 5 years. The second speaker that I'm glad to introduce to all of you is Tona Kupel for AKPO. He is a research and development engineering. He obtained his master's degree in energy management and energy technologies, and since 2016 is working as a development engineer in the team of PEM fuel cell development on, let's say, component development, testing coordination, data analytics of PEM fuel cell data. Now is being part of the German-French joint venture AKPO Fuel Cell Technologies, and is responsible for the development and implementation of future-oriented technologies. And the third and last speaker is Diomedes Valvaso from RINA Consulting as well. He is the Health and Safety Regulatory Compliance Manager. Diomedes is a mechanical engineer with more than 30 years of experience in the management of successful innovation strategic projects in various sectors of engineering and industries, and is currently responsible for the hydrogen safety in several industrial and European funded projects, and is a member of the SEICO mission for the safety aspect related to the hydrogen. So I think we can go directly with the presentation from the first speaker, and we will have time after the free presentation as for the first panel for open discussion from questions from the audience, let's say, present here and connected online.
Thank you, Alessandra, for presenting me, and thank you to organizers for such a nice event. Okay, now I'm ready. So my name is Sergei Pilipko, and I present here Alcogen, that is a solid oxide cell and stack manufacturer. The company was founded in 2001 in Estonia, in Tallinn, where we have today a headquarters. And since 2009, we acquired a subsidiary in Finland that is dealing with the stack assembly. So in Estonia, we have a full cycle of production of solid oxide cells that then are assembled in stack and the stack modules in Finland. Today, we are selling our product worldwide with more than 100 customers in different countries. And also, we are growing recently very fast with today around 120, 130 people employed in both offices. So to explain what we are manufacturing, here you can see on this slide a picture of our cells and the representation with a sand-polished cross-section of its structure below. Our cells, this is a multi-layer ceramic sheet with 7 different layers of thickness between 3 to 400 micron for the 2 commercial products we have for today. The idea is that we are using very common manufacturing processes that can be easily scalable, also allowing us to produce those cells, those core components with different shape, different size to satisfy various stack requirements. Then in Finland, we have two stack products, that is E1000 and E3000. These are quite, in terms of the power range, quite common stack for solid oxide application. E1000 is 1 kilowatt in fuel cell mode, or around 1 cubic meter of hydrogen in electrolysis application. That is more suitable for smaller CHP systems. And the E3000 has a modular structure that allows to get 3 kilowatt from single stack, or 3 cubic meters of hydrogen from a single stack module, but they can be assembled into clusters to reach 10, hundreds of megawatt scale if needed. So our business model is very simple. We are not a system manufacturer. We are providing those core components to our customers. First of all, we are manufacturing the cells. Cells can go to our stack, but also we are sending them to different stack manufacturers, because we believe that the cell will be as a commodity in future, so it is as a consumable, and we want to focus on this core product to be the main supplier. Then our stacks are based, of course, on our cell technology, and then we are also recently introduced a new product that is a stack module, allowing us to reach higher power output. Historically, the main application of our technology was in CHP systems, operating in different fuels, so it can be natural gas, biogas, or hydrogen, from a small size for residential application, going to 10 or 100 of kilowatts for commercial and industrial application. Then also recently we started to receive a lot of attention from maritime industry, who are looking for a very efficient product to power big vessels with a different kind of fuels, because for today it is still unclear what will be the main future fuel for big maritime vessels. And then, of course, it is a big market of hydrogen production and Power-to-X, including production of synthetic fuels that can be done at very high efficiency with a high temperature technology. A bit about our plans for the next several years. So today, as I mentioned, we have 2 entities headquartered in Tallinn and our subsidiary in Finland near Helsinki. And we started a construction process of our new factory that will be first industrial site with a capacity to reach about 200 megawatts if we are talking about electrolyzers, or above 50 megawatt in fuel cell mode, for both cells and stacks. So this will be a fully industrialized place to validate the production, to validate the concept, and then the idea is to multiply those sites and to go to gigafactory level at other places closer to the final customers. We expect that the factory will be ready by the end of the next year, and during 2025 we expect to reach the maximum capacity of this plant. Now, a few examples from our customers, from system integrators, where this technology can be used and what it can give in reality. So here you can see on this picture a CHP system, power generation system, manufactured by Convion, our Finnish customer. This is a 60 kilowatt system that is installed in Estonia near a pilot plant producing biogas from biowaste. This system operates with our stacks on biogas, and you can see that on stack level, the efficiency can be as high as 75% at partial capacity, or above 73% at full capacity. That on the system level gives you the final AC efficiency between 61 to 67%. Depending on the capacity factor. With the tests we have done on degradation, we expect that the stack can survive around 5 years. That makes this kind of system, based on this efficiency, as a very promising power generation technology for future to replace current existing diesel generators. Then another application, for example, if we are talking about electrolysis, again with the same system manufacturer, this is the first system prototype. They are testing the technology, they are testing components, and what we could see that what is the main interest of solid oxide technology, again if we are coming back to electrolysis, is its efficiency, because on stack level you can be as high as around 33 to 34 kilowatt hours per kilogram of hydrogen. That means close to 100% of efficiency on LHV level. Of course, then we need to add BOP components that will eat a part of this efficiency and heat to vaporize steam, water to steam, and to preheat the steam. So in case if the system can be combined with high temperature processes, for example, with the nuclear power or with some other industrial processes, the efficiency can be around 40 kilowatt hours per kilogram. That is much higher comparing to 50, 55 kilowatt hours what we can see today from alkaline or PEM. So that's why there is a big interest from industrial point of view to produce hydrogen using solid oxide technology, and of course we are working on developing, on improving the technology, improving its durability to offer a very high quality product soon for our customers. Also, below you can see that we did some tests investigating such possibilities like dry CO2 electrolysis or steam CO2 co-electrolysis to produce directly syngas as a basis for synthetic fuels. And we see that the technology is also capable very efficiently to allow this concept to be able in near future to recycle CO2 emissions and also to produce very valuable products based on that. One more application that I wanted to show you is also if we are talking that the technology is capable to operate in power generation mode, in electrolysis mode, then with one customer in France, we also designed a system based on our cells that can operate reversibly. In case if we are talking about massive energy storage that is possible through hydrogen, no need to invest in two different systems because it can be done with a single system, with a single cells and single stacks. connected directly to solar panels or wind turbine. In this case, the system is connected to solar panels, and during daytime, it produces hydrogen, and during nighttime, it switches back to power generation mode to produce electricity from the hydrogen. Or in this case, that was calculated, today it is more reasonable potentially to sell hydrogen or to use it for other applications and to use locally available fuels like natural gas to produce electricity from this system. So this is a short overview of Alcogen technology and of main applications, what are possible with solid oxide cells and stacks for today. Thank you.
Thank you, Sergio, for this presentation, which actually was very interesting to see one possible application of hydrogen devices from the solid oxide fuel cell type of technologies. And I think we can go to the second speaker, which will present the other side, let's say, from the two most available technologies for the fuel cells, so from the proton exchange membrane point of view. So I leave the word to Thomas to present your
Thank you, Alessandra, for the kind introduction. It's a pleasure to be here. Thank you, everybody, for being here. And I'm delighted to talk about some really serious topics today. I just want to throw in, firstly, some keywords. So these are energy, hydrogen, resources, and recycling. We all can connect them to the word sustainability. And I want to tell you what our company is connected to this topic day by day. So my name is Thomas Kupel. I'm a development engineer from EKPO Fuel Cell Technologies. So who is EKPO Fuel Cell Technologies? We are a German-French joint venture headquartered in Baden-Württemberg, which is in the southwest of Germany, 60% belonging to ElringKlinger and 40% to Plastic Omnium, both companies from the automotive industry. We have about a turnover of 1.8 billion euros in 2022, and we own 45 plants around the globe and have about 10,000 employees in our company. Plastic Omnium is characterized about threefold the time of ElringKlinger in all these numbers. ElringKlinger brings in its competence in producing components for fuel cells and fuel cell stacks. So we develop them, we produce them, we assemble these components to fuel cell stacks and modules, whereas Plastic Omnium is contributing more on the financial side. They also have a quite complementary business field, so they are also our customers. They build systems, they also produce, for example, hydrogen tanks, high pressure vessels, and so they need our stacks to integrate them in their systems. EKPO at a glance, our headquarters is in Dettingen an der Erms. It's a little village close to Stuttgart. We have a lot of automotive industry around us, so it's we are a good family. Actually, we have more than 230 employees in this joint venture. We address the whole and global fuel cell business, and we have already a production installed that can throw out about 10,000 units of fuel cells. So talking about gigawatt factory, I think with some of our platforms and 10,000 units, we are already a gigawatt factory. Moreover, we hold more than 170 patents in the sector of fuel cells. We address with our products the whole industry, from mainly mobile applications, so more focusing now on heavy-duty applications, but also more and more coming trains, maritime applications, if you read the press, and of course system integrators like Plastic Omnium. So we have a quite broad customer base to address. How do we build our product? Just to give you a little glimpse into that, we have some input materials, raw materials, low-level processed materials, but also some high sophisticated components we use for our fuel cells. But our background is actually from sealings, elastomer sealings, metal stamping, so we are also very professional in injection molding of plastic components, and these are all components we need for the fuel cell, as you can see in the processing phase. So the bipolar plate, so we can stamp metal quite well. We built the bipolar plate as the core component of, or one of the core components of our fuel cell stack, and the GDL we buy, but we inject mold a seal on it, and so we call that seal on GDL. Adding a CCM makes already a single fuel cell out of that. Adding the components, or multiplying this component or this assembly, we get a fuel cell, a cell row assembly, and putting some end plates and media supply assemblies on it, we already have the stack. That will be compressed. We put some sensors on, some valves, some media connectors, and a housing. Also, not to forget the fuel cell voltage monitoring. And if end-of-line testing is okay, we can deliver our products to the customer. What are our products? Just a quick overview. We have different platforms called NM5 Evo, NM12 Single, NM12 Twin. They all have in common, they address the high volume automotive applications, and they are characterized by a high power density, 6.2 kilowatts per liter, cold starting ability, and of course all the automotive standards that are required by our customers are met, like IP housing, EMC shielding, cell voltage monitoring, sensors, actuators, and so on. These different platforms have different power ratings, so NM5 Evo, you can have like a low cell count starting from 71 cells, so it's about in the 20 kilowatt class, over NM12 Single with like 120 kilowatts up to NM12 Twin with 205 kilowatts. Our roadmap and technology, if we look on the component side, we started quite early in 2000 already, just building bipolar plates for customers, beginning then also to build our own stacks in 2010 based on graphitic bipolar plates, switching to metal bipolar plates. We are a metal stamping company at Klinger, and of course developing several platforms like I just told you, NM5 Evo, NM12 Twin, and so on. And of course for the next generation we have already in focus, we want higher power rated systems up to 350 kilowatts and also high efficiency systems. On the side of our customers, we of course also develop for components for customers, but big milestones in the past were definitely in end of 2022, the joint venture between Airbus and Klinger. This joint venture is called Aerostack, and of course where I'm working at the moment, EKPO, the joint venture between Klinger and Plastic Omnium in the beginning of 2021. Just a little overview of products we have in the field. So we have products in funded projects like in this H2 Hall, in this truck we implemented, or the project implemented an NM5 Evo system, but also special applications like the car you can see there from the Rally Dakar. There's an NM12 Twin implemented, but also series order from logistic companies. They implement the NM5 Evo systems like for forklifts. We deliver them already in series production. Also we have in a plant in China to serve the Asian market, and also some corporations there. For the future outlook, of course, there are more and more customers demanding components, but also the development of fuel cell stacks, inclusively tooling and prototyping. To give you a little twist now to come back to the sustainability topic. I want to show you how our stack is built up. So this is the example of the NM5 Evo stack, 335 cells, inclusively housing. So you can see that we have quite a lot metal parts here, stainless steel, aluminum, which is already like 3/4 of the whole mass of the system. Then of course we have elastomer, plastics, copper, electronics, GDL, and CCM only in a very small fraction, but very important, very precious. I mean, that's why we have this project Best for High, because it has such a high impact if you consider life cycle assessment and emissions. So for the recycling properties, since we use metal bipolar plates and aluminum housing, so this is quite good. We have well-established processes, but for the elastomers, it's quite difficult. These are like cross-linked polymers, difficult to recycle, and also the GDL is a very special material which is difficult to reuse or to recycle, or maybe downcycling is still one of the options. Just to pick out the elastomers, what do we do here actively to tackle the sustainability topic? We switch our sealing technology concept towards screen printed microseals, so we could reduce 97% of the mass since we need way less elastomer. So this is a good thing because elastomer is difficult to recycle. And of course also we are looking for fluorine-free sealings. I mean, in the fuel cell with these harsh conditions, we need high-end materials to just meet all the requirements, to meet durability, performance, and so on. It's really difficult to find proper materials for the fuel cell applications. This is just projected on the NM5 design or NM5 Evo, but this technology will be available in all future stack concepts we are developing on. Just to finalize the presentation, topics we always consider if we develop a fuel cell, which are connected to sustainability and recyclability, are how can stacks be disassembled safely? How can the components be easily separated? How can we support the separation of components for a serial process? Which parts can be recycled or even be reused? How can the recycling aspects be considered in the stack concept already? And how much recycled material can be used in every component in our fuel cell stack to still fulfill the requirements? So I think sustainability is not just an empty phrase nowadays. I think this is a really important topic we have to tackle. Otherwise, I think recent events and scientific research shows what could happen if we don't take this topic serious. Thank you very much.
Thank you, Thomas, for this as well interesting presentation, and you already start to go a little bit more in detail on the sustainability of the supply chain of the fuel cell, which is one of the topics we'll go maybe a little bit more in details during the panel session. I would like to introduce the last speaker. Let's say we already talked before on safety issues related to the hydrogen technologies, so I leave the word to my colleague, Diomedes. We will present you some aspects related to the safety and regulatory compliance of the hydrogen.
Good morning, everybody. There was a short presentation. I would like to start from a comment I heard a few minutes ago in the first panel presentation about the need to have regulation developed for hydrogen application. The need of regulation, and mainly regulation for safety aspect, health and environmental impact, the need of regulation is a basic necessity of every society. We as RINA work in this field since centuries, you can say. I joined RINA about 20 years ago, just to follow regulation for a new ambition project for liquid natural gas, when liquid natural gas in 2000-2003 was very well known in United States, but not in Europe and mainly in Italy. Before, I had an impact of the need with the regulation related with another safety product, which is airbags. Airbags, as you can see now, are perfectly integrated in our transport safety system, but you should imagine that in 1994 it was considered an explosive component. So it was ruled by regulation as explosive with the rules related with weapons. It was a tough job for me personally and some colleagues who is here with me today to change the regulation and to update the regulatory body and administrative authorities in Italy to recognize the safety aspect and the technology improvement about this product. The same we have now with hydrogen. Hydrogen has a long story in the technology. RINA knows very well. I have a presentation of RINA I would like to follow, but it is important to give you this information that hydrogen is now, from a technical aspect, a safe product. So we can manage this product following all the safety measures, and engineering solutions are already in place. So there is nothing to invent to make hydrogen safe. The challenge is to make hydrogen profitable, to make hydrogen performance at the best level. But there is another challenge, is to share information and awareness about hydrogen safety and hydrogen risk connected with the use, the production, the manufacture. And this is a work for engineers. So we are mainly engineering consultancy company. We can move to the, or I have to, from here, right? Let's see. Okay. We are a consultancy company with about 5,300 people all around the world. We heritate Registro Navale Italiano know-how. Registro Navale Italiano born in 1863, but it heredited the tradition of the previous state naval registry, or let me say, agency for flag administration. So Registro Navale is a very well-known realty related with safety. Safety burn, which started in the field of marine industry to give assurance with marine transportation. But now, since 2000, we spread our knowledge all over industry and energy, mobility, real estate, and infrastructure, space, and defense industry. So we are now giving our support in mainly all fields of engineering. I am in charge of this new organization, which is a part of the health and safety engineering. So we give support to engineers. We are a consultancy. We don't produce goods. We don't produce a project. We just give support to engineers on the side of health and safety. We are 20 specialists. We have some scientists, the others are engineers. We have office in Genova, in Milano, in Livorno, and in Rome. And I'm particularly following now the HSE regulatory compliance. But we have also a dedicated department for major accident hazard and fire prevention, risk safety, and reliability. We have a project open all over the world. This map is not updated, but we started the project also in Antarctic continent, where I was some months ago. So we have a customer everywhere in the world, giving them our support in the field of engineering for safety. Because the safety, first of all, has to be designed, then has to be applied, and has to be known. So the awareness of safety is the key in all the fields. We do risk assessment. Risk assessment techniques are not easy to understand, so requires a specialist approach. We give support for training of engineers, training of managers, training of operators, of workers, training on safety and on rules to apply, methods, and also we try to build a culture for safety. We do health and safety engineering, asset integrity support, regulatory compliance, and health and safety management support. Speaking about engineering, mainly we are involved to give support for the safety of pressurized equipment. Pressurized equipment are covered in Europe by Pressure Equipment Directive. We give support for explosion and fire protection. So there are many methods to produce hydrogen. We know very well hydrolysis, and we know also steam reforming. And all the plants of steam reforming in Italy and many in Europe and also outside Europe have been designed with our support and our test and inspection engineering support. We give also support on the safety instrumentation. You know that when you have an hazard, you can mitigate the hazard with detector system and alarm system, and this detector system requires a strong reliability. We give support on design and assessment of the reliability of the safety systems, which is called seal assessment, seal verification. All this matter is very well standardized and regulated by norms, standards, which requires a specialist approach. Then we give support for safety of machinery. So this is a requirement. We have experience of this in the day-by-day life, everyday life of everybody of us. The contact of the person, the human contact with the machine is a critical interface boundary which could generate problems, fatalities, and must be kept under the correct attention, especially during the design of a machine, but also during the construction and the installation and the operation and the maintenance. This life cycle of a machine should be followed by an approach keeping in count safety as a first goal to be reached. And then we have also noise assessment capacity for the facilities in place. We can show. I have presented all the activities, so you can check. You will have a copy of this presentation, and you can check what is of your interest and ask for more details further. But training is very important. Risk assessment, we have a quantitative approach and we have a qualitative approach. Then in the quantitative, we have also the simulation of operation of a facility after design, but before manufacturing and installation. There is also a method that is very often required by our customer, which is the bow tie system to check the hazard and to find the mitigations. This system is, for instance, very often used by oil and gas companies all over the world, and it is requested very often to us, and we can apply this method also at hydrogen installations. Then we can, HSA management, we follow the companies in the during their operative life to maintain a correct safety approach. So when we can give support to our customer during the concept stage, the feasibility study, the design, the detailed design study, and construction. We can give support. We give support during construction, during operation, during decommissioning, and during maintenance. So this just to give you a view of the activities of me with my group and with my colleagues and all the body of 5,300 RINA engineers are committed to provide to our customers in all the engineering and industry and energy field. Now I would like to show you some project we are following specifically with hydrogen. Hydrogen, first let me say, project, important project, I think one of the main, is a new test facility project of Enel, you know Enel company, which is developing for equipment, hydrogen equipment in all kind of application, from storage to electrolyzer to BESS to components and to fuel cell. So we developed for them the regulatory compliance plan. It was not easy, it was a work of 1 year together with a team provided by Enel to find all the regulatory implication. This allows us to contact directly the authority, so the Minister of Interior. We open a working table with the fire brigade in Rome to develop new regulation, a new approach for this kind of equipment. Still is open this collaboration with the authorities. So just to close, you can see all the other projects. There is the Hydrogen Valley in Ticino. Just to give you the carbonization project, we are doing injection of hydrogen in the domestic field, in the kitchen, to cook, to boil the water, to heat the water for the restroom, and so on. Just, I would like to give you the last information, which is I think very important, is that it is developed now, it is available now, a new standard, ISO 22734, which is a standard for hydrogen generators using water electrolysis, industrial, commercial, and residential application. And ARENA is the first Italian certification body, among the first in Europe, to receive accreditation from ICRIDIA to the international standard. This allows us to give support to all the manufacturers of this kind of products to certify the products, and this certification is based on several other certifications already mandatory, which are Machinery Directive, Pressure Equipment Directive, Explosive Atmosphere Directive, with the standards about the safety integrity level of the equipment and of the control system, and with the standards and the methodology about the hazardous operation risks assessment, which has to be done in the design stage and along all the production stage of this kind of machine. So I think I closed my time, right? So I just would like to close my intervention with this sentence: technology proceed on the path of safety and sustainability towards a future of progress, or became extinct. Thank you for your attention.
Thank you, Domede, for this presentation that combines, say, what we already see before and during this panel for the safety aspect, for the production, storage, use, distribution, and use of the hydrogen. I would like to start the panel discussion with a pool on to understand from the audience, from your point of view, which is the main barriers for the uptake of the hydrogen technology. So if it's from your point of view, an economic barriers for the, let's say, cost of the hydrogen, it's a technological confidential barrier, a safety concern, or a regulatory barriers. And in the meanwhile, you have time to answer to the poll on Slido. I would like to open the panel discussion with the first question to our speakers on sustainability. We talk a lot on sustainability. It will be the last panel on sustainability again, but also combine with the question that we already received from the audience online. I would like to understand, mainly from Elcogen and EKPO as a fuel cell manufacturer, which is the sustainability of the supply chain for your technologies, but also considering from one point of view, if from your experience, the customer are sensible to the sustainability. So your customer asks you to demonstrate if you meet certain requirements on sustainability aspect, as well as if you as a company, as a technology provider, let's say, ask to your supplier for maybe mainly from the material point of view, if you are able to work and manufacture your technology, your solution, considering all the sustainability aspect. So you are a sort of in the midpoint between you have supplier that provides you the materials to construct technology, and you have the customer who would like to use and buy your technology. So also in this sense, in this overview, which is the rule of sustainability, and from, let's say, directly from your point of view.
Okay, so thank you for this question. I will try to answer first. It is a big topic because the main question here is what is exactly sustainability? Need to precise what are we talking about? Is it related to CO2 or like a full value chain or to something else? But today we are at the birth of the hydrogen industry, renewable, green hydrogen industry, let's say. And today the main, I like this question and I see that people understand what is the main barrier today. The main barrier is cost. So that's why, yes, of course, we are talking with our suppliers. Our customers are asking us about sustainability aspects, and we are working on them. We are thinking how to improve the usage of resources. We are thinking how to make the production cleaner. But the main question today is still economic aspect and security. For the solid oxide industry, supply chain security is a bit easier topic because we use very common materials. Even if we build 10 gigafactories, we will not change too much the consumption of zirconia and nickel oxide that are our main components. We of course use some small amount of cobalt and rare earth elements, but they are quite negligible in the overall value chain. It might be different for low temperature technology, for PEM technology, but for us today, I think that by the end of the decade, sustainability question will be more and more important, but today this is more security of supply chain and cost.
And from a KPO point of view?
Yeah, we are also recognizing that sustainability is coming very much into focus from our customers actually. So of course we also get the focus, and we also put our suppliers into the position that they need to talk to us about sustainability topics. And I think Sergi already mentioned really well what is sustainability, what are the impacts on our environment. So that's also why we have this fantastic project of Best for High, which addresses a lot of these topics. And also internally at EKPO, we have a dedicated team that takes care about that. So of course we have economic aspects. We want to come into the market with our products, but the materials sometimes are not available. Let's just talk about fluorinated components. You know, this is probably not a very sustainable material that we use or ingredient for our components, but at the moment this influences a lot the economic aspects like lifetime, durability, power, and so this is a very big aspect hindering to switch to other technologies, maybe fluorine-free technologies. And this is also then already interconnected with regulatory barriers, since the PFAS ban is like forcing us probably to look for fluorine-free materials, which of course will be in the end more sustainable, but could hinder that we bring our products to the market. And so yes, I mean, we try at all different parameters to be more sustainable for our product, to make our suppliers more sustainable. Also, I mean, the measure every company does is like installing solar panels, using green production, and so on. But definitely, I guess the economic aspect, as shown in the poll, is really, really tremendous. Yes, thank you.
Thank you. Yeah, let's say we see that, and also from your answer, that the economic aspect is currently one of the main barrier for the uptake of the hydrogen technologies. But we see as a second, let's say, main barriers are related to the regulatory aspect. And what I would like to ask to all of you, actually, also involving Diomede, which is very active in regulation related to the hydrogen. If the regulation could have a positive impact also on the public perception on the use of hydrogen technology. So if the regulation body could have a rule for the uptake of hydrogen technologies.
Yes, the awareness about the safe application of hydrogen among the skip holders should increase. And the current regulation is under reviewing. I mean, when a technology increase the impact in society, regulation take care in the time of the product, these kind of things. This was stop. I should go back to the story of hydrogen. Hydrogen had a very great beginning at the beginning of last century and stopped because a safety problem. I think many of you remember the story of Zeppelin. Zeppelin in 1937 was hydrogen flying machine, we say, and there was a great accident, but it was not so great because in respect to other accidents we had next time in the following years. Nevertheless, the impact with the regulation at that time was great, and we inherited a point of view about hydrogen mainly related with the hazard, rather than with the aspect of sustainability. So the regulation will be sure under the review to give space to the technological improvement, to the technological progress with the new safety instruments, tools, both in engineering and in technology and in instruments we have now. So the efforts on regulation review should be keep high. So and the awareness of the need to improve the regulation is really important. But this does not mean that we have not the standards and we have not the technical rules about hydrogen. We have this. We are able to perform risk assessment with acceptable and high technological results and high reliability. The awareness inside the regulation has to be increased.
I don't know if also you would like to add something on that point.
I would like to talk about regulatory barriers a bit from another side, that in my opinion also regulatory regulations should be motivating new clean technology to be implemented into real life. Because today we are talking, of course, economic aspects, transferring everything into money, but we are omitting the part that ecological side. So that is, we still are not quantifying how much does it cost, how much we are damaging the environment with the current technologies. And I think that to really push the hydrogen technologies further, the regulations should also develop, not only in Europe but worldwide, a very clear some kind of CO2 passport evaluation, and then CO2 taxes that will be applied to non-clean technologies, non-clean energy production, storage, transportation, that it should be, at least in the main industrial areas worldwide, it should be regulated.
Just to add another aspect from EKPO side, I think regulations are important, but we should not over-regulate. I think regulations need to be established in cooperation with the authorities and with producers, with system integrators, with all the stakeholders and actors to find a viable way not to slow down the time to market, that products will come to market too much. And I think if we all pull on the same string, this is possible, but I think this needs a lot of communication to find the right level of regulation.
Thank you all. Yeah, you all of you get very important insights for the discussion, which can continue, say, later on during the networking opportunities or the lunch break. And since we are a little bit over the time, I'll leave the word to Ilaria for the last panel of today. And thank you so much for the attention.
Thank you.
Thank you very much all. So we are now at the last of our panels for the day. The panel is from eco-design to end of life, a circular and sustainable value chain for hydrogen. I will be the moderator for this session, and I have the pleasure to call as panel members some of the partners of Project Best for I, which I will introduce as well in a minute. So let me call on stage Anna Marchisio, Business Development Manager from Ensor Recycling, Germany. Anna holds a degree in Humanities and German Studies from the University of Turin, so she's actually from this city itself, but she's actually working in the PGM, so in the platinum group material sector, after many years in the automotive sector. She has been regional area manager, key account manager, institutional relations manager, international sales manager, so you get the gist. Anna is now an international business development manager for Ensor Recycling Germany. She has solid experience in the critical raw materials industry, and especially on recycling and salvaging complex device and application containing platinum group metals. So thank you, Anna, for joining me. Then I'd like to call on stage Valerie Kapeliushko, Sustainability and Strategic Initiative Research and Innovation Manager from Solvay. Valerie is a chemical engineer and a doctor in chemical engineering, and specializes in high performance polymers. He has about 70 patent families to his names and 20 articles in his portfolio. He specializes in fluoropolymers and high performance fluoropolymers research and innovation. Since 2021, he's head of advanced research and sustainable technology in Solvay Materials. He is leading an international team focused on strategic research and sustainable technologies development, and is specializing on sustainable development. So thank you, Valerie, for joining us here. Then I'd like to call Associate Professor Mizia Mori. Mizia is Associate Professor, member of the Department of Energy Engineering at the Faculty of Mechanical Engineering at the University of Vienna. He's a leading expert in LCA in Slovenia, and not only. He collaborates with industry, international projects, government. He works on life cycle assessment, carbon footprint, hydrogen economy, and eco-design, and is especially following and leading work packages on life cycle assessment and sustainable life cycle assessment studies and techno-economical analysis in several European funded projects. And thank you, Mizia, for being here as well. And last but not least, I'd like to call Antonio Campanale from RINA again. Antonio is a project manager at RINA Consulting. She works in the group of innovation for power generation and hydrogen. Is an energy engineer from the Politecnico of Turin. He's recently joined RINA Consulting, working on the management of EU-funded projects. So thank you all for joining me on stage. Before I start the presentation, I'd like to call up a poll again. So this is a poll, is a free text poll. So what we are asking our audience today is which are the research and innovation areas for improving the sustainability of the hydrogen supply chain in your opinion, just type 2 or 3 words that in your opinion actually explain in which area the supply chain should work to improve the environmental sustainability of the hydrogen supply chain. Okay, and as I said, I'd like now to give you a brief introduction of the Best for I project, which I am coordinating since the beginning of this year. This project is on the sustainable solutions for recycling and end-of-life hydrogen technologies. It's a project which is now arriving to the end of its 3 years, and you are meeting today, and you will be meeting also this afternoon, all the partners involved in this very, very interesting project. So what we did in this project, we focused on developing and validating some existing and novel recycling processes for 2 key fuel cell and hydrogen products, so proton exchange membrane fuel cell and solid oxide fuel cells. We worked on closing the cycle, so we worked on ensuring that the material recovered could be applied, used back into the manufacture of PEM stacks and solid oxide fuel cells, and therefore we are evaluating how they are performing in these remanufactured elements. We studied life cycle costing and life cycle analysis of these end-of-life strategies, and this allowed our project to contribute greatly to understanding of the whole life cycle of the hydrogen technologies. We also looked at regulation and standards on techno-economic analysis, and also we developed some training material, and indeed this afternoon you'll have the opportunity to see exactly what these recovery and recycling technologies are, and to see what we have managed to produce with them. So this is a representation of our project concept. We had quite a few challenges, you can imagine, starting from how to best dismantle the stack, arriving from end of life, to understand how to ensure we could maximize the active materials that could be then sent to the following step for the recovery of the precious materials, so minimizing material loss, and also experimenting on gas dismantling technologies with CEA to maximize the recovery efficiency and using low environmental impact chemicals. So from the dismantling of the stack, we then went to study the recycling technologies, the recovery technologies for the materials, the key materials for the 2 technologies. We focused on platinum and ionomer from PEM fuel cells, and on nickel and yttria-stabilized zirconia from solid oxide fuel cell. We managed to develop some technologies up to TRL 5. We were starting from very low TRL. We've also explored how to recover lanthanum and cobalt from the cathode side of the solid oxide fuel cell. Finally, our challenge was then to integrate this recycled material into the new MEAs, so integrating the platinum and the carbon catalyst synthesized from recycled platinum salt into the new MEA for the PEM fuel cells, integrating recycled nickel oxide and YSZ into the new soft cells, and then evaluating the performance of these remanufactured elements. We are nearing the end of this project. We have obtained some very interesting results, more will be said this afternoon about them, but let's say that we have been able to recover platinum with a very high efficiency, applying different type of recycling technologies, and also managing to produce some precursors which could be used directly for the manufacturing of MEA. We've also managed to recover spent membrane and GDL, and managed to recover also at very high percentages the nickel yttria stabilized zirconia, both from scrap cells, so from a production scrap, and from the end of life of solid oxide fuel cells. The technologies we developed having in mind the pursuing of a very low environmental impact of them. So conditions that we have been looking at are mild as much as possible, and we've explored the recovery of reagents to make sure that the emissions are limited. Very high percentage of recycled materials have been used in manufacturing new membranes and new solid oxide fuel cells, and now we are actually in the process of evaluating how they are performing with respect to fully virgin materials elements. So, as I said, more to get to know this project this afternoon. From 2 o'clock in the room next door, you will have the opportunity also to meet the main actors of this process development. But now I have the pleasure to leave the floor to Anna Marchisio from Ensel Recycling, which will explain us how the company is working on recycling and recovery of platinum. Thank you.
Thank you, Ilaria, and thank you everybody for attending today. Well, I'm going to offer you a short overview about what our group is doing and has been doing, and how we are approaching the recovery of critical raw materials within complex fuel cell hydrogen systems. So just a few words about ourselves. We are a German family-owned company. We've been celebrating our 25th anniversary this year. We have a presence all around the world. We are present in the 5 continents with one main site near Frankfurt and other 7 facilities scattered both in Europe as well as in the United States and in Southeastern Asia and Australia. We have 2 representative sales offices as well in South Africa and in the Czech Republic. South Africa is easily explained because there is where the main mining facilities are, and this is why it is important to be there in presence, because of course we also cooperate with the mining corporations. Our services range from the recycling of different devices containing precious metals, and in particularly platinum group metals, but also goes to the offering of financial services and the management of commodities such as platinum or other metals of the platinum group, which we also make available for the industry, swapping them into so-called pool accounts or selling them in future at the stocking exchange. I will not bore you with the list of certificates we dispose of, and neither with our memberships. So basically what we do is quite simple. So we tried to make an easy scheme of our actions. So our main customers range from scrapyards and muffler shops and other recycling facilities and industries, and go up till to OEM and industrial players. What we do is that we collect physically the material which are end of life, classified end of life, which are subject to different classification. We try to determine theoretical value of this material. This value is the value that we settle with the majority of the small range customers. And then we proceed with the dismantling and disassembling operations. Our DNA is very deep in homogenization and sampling procedures. So we are able to produce representative samples starting from a very kind of heterogeneous materials. After that, of course, there is an analysis and determination, both with spectrometers and XRF, but as well as by means of ICP-OES. And then once the value of the material recovered has been effectively determined and settled, there are the financial or the industrial operations in order to make the material available for a closed loop utilization again. In this sense, the Hanser Group gives a significant contribution to the environmental relief, because as you know, platinum group metals are classified as critical raw materials. They are present in some geographically sensitive areas, which are pretty much unstable, like now Russia, the Russian Federation, as far as palladium goes. There is an embargo going on also for these kind of metals. South Africa, Zimbabwe, partly United States, and that's perhaps not so critical, but I mean, the European Union has been talking for ages about the necessity of its members to be able to be independent from other players in order to be able to develop environmental friendly technologies, having sufficiently enough of these kind of materials. Besides that, the mine production is extremely energy consuming and also contributes greatly to the production of CO2. Of course, even recycling activities contemplate some energy dispersion, but as you can see, compared to what we have in mine production, I mean, it is for sure a better bed, let's say. It's a much less worse impact. The recycling industry contributes also greatly to the recovery of precious metals, which are then reintroduced into the loop, and the Hanser Recycling Group is contributing for 11 tons. Yes, and talking about CO2 and primary mine production, we have an average of production. These numbers come from 2 years ago, so they should be updated now, but we are talking about 15,600 kilo of CO2 per kilogram of material excavated. Of course, the biggest players in the mine industry are, for instance, now starting to use mining excavators which are fueled with hydrogen or which are at a very low CO2 impact. But nevertheless, you have to imagine that when you excavate looking for platinum, for instance, you need to excavate 1 ton of earth in order to get about 1 gram of ore, while instead with the recycling of a spent catalytic converter, I mean a single unit, you have a little bit more than 1 kilo of ceramic monolith, and you get already more than 1 gram of platinum as a comparison. Yes. So, where do we get the PGMs from? Well, mainly from ceramic catalytic converters, but also diesel particulate filters. The ceramic catalytic converters are mainly based at, the carrier is made of cordierite, while the diesel particulate filters are mainly made of silicium. And of course, metal foil converters. We also give information to our base customers about what the value of the materials that they are purchasing around is, and this thanks to an application that we've developed and we keep on developing, which offers in real time the value of a spent catalytic converter unit, regardless of the make, because they are stored. Up to now, we have about 18,000 serial numbers and still growing. Of course, platinum group metals are not just to be found in passenger cars, catalytic converters, but also in other mobility systems such as lorries, buses, but also in stationary systems such as natural gas and biogas plants, and recently also chemical catalytic converter systems, pharmaceutical catalytic converter systems coming from different industrial applications. Further materials we are tackling are oxygen sensors, parking plugs. They contain iridium. We are having a pilot project at the moment within the group in order to recover iridium from sparking plugs, but also different components coming from electronic and electric devices. So electronic control units, printed circuit boards of many different kinds, and of course, coming to the subject of today is reunion fuel cells and electrolyzers. Of course, fuel cells and electrolyzers are both stationary and in mobile applications. Our challenge here, even within the Best for High project, was how to disassemble, separate, sample and assay this kind of material, which is of course extremely varied and extremely complex in the assembly. This has brought us to focus on the CCM, the carbon-coated membranes, which have of course show a high platinum content, and in case of electrolyzers, iridium and platinum together. Alongside, of course, there are other recyclable materials which are worth trying. For instance, the ionomer membrane, and we are approaching that subject now, though it is not really in our tradition of materials that we are handling with, but we think it is worth trying. Of course, there are not just materials to be recycled, there are also materials to be reused and refurbished. And we think that the fuel cell systems offer an excellent example for that, because we have been dealing with many different materials such as bipolar plates made of titanium, made of graphite, made of stainless steels, with gold coating, without gold coating. So there is really a full range, and the big challenge is also how the technology is going to progress and how quick, in order to understand if we were we will be able to reuse bipolar plate that has been built in 2005 for a system that perhaps will have to be built in 20 years. These are mainly the metals we are concentrating on now. You see also cobalt, it in gray, because it is not a precious metal. It is rather classified as rare earth. I think it does not impact so much the PEM fuel cells, but is still relevant as an element that we are talking and looking at regarding very important subjects as also social security and conditions of work in other parts of the world where we also get as Western our materials. Talking a little bit about the ionomer recovery, well, we developed within the Best4High project 2 ways of recovering platinum and ionomer. On the first step, using known technology, which is via hydrometallurgical methodology, so simply having the CCM shredded and diluted in aqua regia, in acids, and then precipitate into hexaplatychlorinate salt, which we are able to recover in-house. And the other method, which is even more environmental friendly, is via alcohol dissolution. And with this method, the ionomer membrane doesn't get destroyed, but has got the possibility to be recovered in a diluted solution and eventually be characterized and perhaps, hopefully, be accessible and available again. So we are looking at this second aspect with some ionomer producers. In this sense, our role is to make this material available to be characterized, because we run a completely anorganic laboratory, and this kind of exercise needs an organic laboratory. So, and this is like short overview. I hope perhaps if you have some questions we can answer later. Thank you.
Thank you very much, Anna. So I've been informed that perhaps the Slido hasn't quite been seen by everyone, so let me just go back to show you the Slido question again, and then you can actually provide some of the direct, here you go. So you can actually see, this is the question, this is a 3 words question, so tell us where do you think research and innovation should focus for improving the sustainability of the hydrogen supply chain. Thank you very much. And now let's get back to our panel. I have the pleasure now to call Dr. Capeliusco from Solvay. Anna spoke about the recycling of precious metal. She introduced the subject of ionomer recycling, and Solvay is working on ionomer, so it will be interesting to see what you're doing. Thank you, Valerie.
Thank you for introduction, and thanks for this very nice opportunity to present our activity in the field of hydrogen economy. Thank you. Just a few words about Solvay. Solvay is an international chemical company, 160 years old. And from the beginning, the company was based on science. So it was innovative breakthrough discovery of innovative process to produce soda. And the company maintained this passion for science during this 160 years, and it's a part of its strategy to develop innovative solution for society need. that changed during this 160 years. And as a part of this strategy, a few years ago, we created a hydrogen platform. It's a platform to provide innovative material for growing, and now it's really in transition hydrogen economy. We provide several innovative materials for hydrogen production, like membrane for PEM electrolysis, but also structural component, high performance thermoplastic, polysulfone, PEEK, PPS, that permits, cost effective construction of equipment at high pressure. Then also storage, in particular high pressure gas hydrogen storage. Our material are thermoset and thermoplastic composite, that really cost-effective solution for high pressure hydrogen storage, in particular for transportation, where this is the only technology used today. And last but not least, fuel cell, in particular fuel cell transportation, where both PEM membranes and also electrodes are constructed using our materials. One of the most important polymer from our hydrogen platform is Aquivion perfluorinated ionomer that we produce integrating this value chain of hydrogen economy from the beginning. We start from very base chemicals, and we produce perfluorinated ionomer, proton conductive material, in the form of dispersion powders with different properties, conductivity, equivalent weight, that our customer can convert in membrane electrodes and develop a final device for, as we discuss, fuel cell electrolysis and also redox flow batteries. That is a collateral application. Just a few words about Aquivion. There are many different ionomers on the market. We believe that our material is highly differentiated. It's a so-called short side chain that provide several advantages comparing to historical material like Nafion with a longer side chain. In particular, it's a high glass transition temperature. It permits operation at high temperature. In particular, in automotive, it's important. And also, this material can be at low equivalent weight, still maintaining crystallinity. There are different ways to exploit this advantage. One material can provide higher conductivity at the same equivalent weight, or provide a higher crystallinity. Last comment related to recyclability. As a previous speaker presented, we conducted some study on lab scale on recyclability. This is a part of transition to circular economy, and as a whole plastic industry, we are working on this topic. And the material is highly chemically stable, that really enabling recyclability. So it means even after, I could say, 20,000 cycle end of life material can be recycled by standard chemical processes and reuse to produce a new membrane or electrodes in the same application. It's already demonstrated at lab scale, and we will move to production once end of life could say supply chain will be available, because as any recycling project, this requires technology, but also a reverse supply chain. So it's not, say, just theoretical exercise. We need volume, and means, for example, speaking end-of-life vehicles need really, end-of-life vehicles as a disassembly with a real supply chain to scale up this process to industrial scale. I finish here. Thanks for your attention, and thanks again for organizing.
I think we will pick up this comment a little later on in our discussion. Let's go to the next speaker of this panel, which is Professor Mitya Mori, who will be illustrating also a sister project to Best4i and how the two projects have interacted. Thank you, Mitya.
Hello to all. Thank you for organizing such an event. It's a pleasure to be here. So I will try to present you actually the steps that we made in the life cycle sustainability assessment and somehow try to go hand to hand within three projects, partnering projects under Clean Hydrogen Partnership. I will briefly go through the steps of eco-design that were taken within ECO's project. I will stress out the importance of the collaboration with the industry that because junk input data will provide the junk output results, so this was the most challenging and the most important collaboration. Then how we approached eco-design and define production concepts from in eGhost, so from one base case stack to the let's say 4 production concepts that we defined, and then how we combine the results from the best for high, because when you go in the eco-design, we will see later, you don't just tackle manufacturing phase, but as much as possible the whole value chain of the product. I will briefly just present some LCA results, and since I will also try to present the results of the LCC and social LCA. As I said, 3 partnering projects were, and the stepwise approach was taken. The basic inventory was gained from the industry, and then the eco-design wheel was included, and together with industry we set up product concepts, and we defined new innovative inventories based on these inputs that served for LCA, LCC, so life cycle costing assessment, and also social LCA that is going a step beyond LCA and LCC approach. And then, of course, results and analysis will serve as a white book input that will come out as the result of all 3 projects, and mainly from the egos, but you will see how the combination of the results and approaches was included. So eco-design, we went to the eco-design wheel where we, from the base case, we did 4 additional product concepts of the stack. So the base case was the 1 stack from 1 industry partners, and then with the industry we defined the approach where we can tackle, let's say, some reduction of material, some better power to weight ratio, and we defined that in 4 concepts: realistic short-term, realistic mid to long-term, optimistic, and 1 destructive at the end that is actually needed technology to be completely changed to be able to go to that. You can see the eco-design wheel is tackling different part of the value chain, so from the manufacturing phase to the end-of-life phase. That's why all the inputs from the best for high projects were important. And here are just maybe the numbers briefly, how material reduction in different concepts was defined. And of course, the reduction of material is mainly in the manufacturing phase, but when we go to the end-of-life phase of the product, we defined different scenarios. So it was a closed-loop scenario that we can use the material back in the same technology, or if we don't, in one concept, we do not need so much material back because it was defined just, let's say, 30% of recycled platinum input and 70 of the virgin platinum input. We did the remaining part to the open loop recycling, so to be used in the other technologies in the open market. So we tackle platinum, bipolar plate GDL, Nafion as a material reduction, closed loop recycling and reuse platinum, the same, and also the end plates and a bit of copper. And then we also tackle with the power to weight ratio improvement as suggested by the industry. So at the end, what was really the novelty of everything was inventory databases, data sets that are now available and will be also soon published in the scientific publication to be used. And we are also cooperating with joint research centers, so some of the data sets will be available in aggregated mode also for the use of in the cases of other LCA practitioners in the future. So when we came to the end of life phase, I already mentioned we had to include the best for high results, and you can see here the scheme of the recycling of the platinum that has to be translated or had to be translated into the LCA environment. So it was quite a challenge because all the processes here are relatively on the low tier level, but for the really clear and qualitative LCA, you have to have very exact inputs of the mass and energy balances, all the waste flows, etc. So it was quite a miracle, and thanks to all the partners that we were able to accomplish that. The models now are here, and it will be improved with the new data, because when this will be scaled up, of course the energy efficiency and also the mass balance efficiency will be higher, and that's why the environmental impact of the recycled material will be even lower. But already now we managed to show significant decrease of the recycled, let's say, platinum group metals toward to the virgin production one. From the third project, I was mentioning EGOS, then Best for High SHE project, we included the approach of the life cycle costing, where we actually calculated from the same inventory the cost of the recycled platinum, including all the capex, opex, working hours, shifts, prices of the stacks on the input, prices of the platinum as the valuable material on the output. So also these results will be soon available. So here are just results for the LCA and just for the carbon footprint. I'm not showing that because I relate just to the carbon footprint in the LCA case. We know that there are many environmental impacts indicators that has to be addressed, but it is most clearly understood, understandable, and also all other indicators are showing the same approach. We can see here this the one column, the biggest column is base case, so it is per stack 1.2 tons of the CO2 equivalents, but already there we can see on the bottom in the end of life phase some potentials of the avoiding impacts. What are these potentials? As I explained before, if we do not need some material in the closed loop recycling in the same technology, we can make open loop recycling to be used in the other technologies in other company. So these are materials that are on the market, are recycled, and since are from this technology are offering some avoided environmental impacts, of course, compared to the virgin production on the other side of the same material. And we can see that all these concepts are showing from the short case say, a short-term, mid-term, and then the optimistic one, that is the fourth one, and disruptive one, that the expected lowering of the environmental impacts is there. That is that we didn't know if we will be successful. These are almost ideal results, of course, but what is very important, that the inputs are not from the academia, because we can manage to do whatever we want, but the inputs of the definition of these cases are inputs from the industry. Shortly to conclude, or maybe just to jump to the since I have, let's say, half a minute, I would jump also to beyond LCA, to the life cycle costing and the social LCA, that are actually the whole three pillars of the sustainable development. Here I have just two concepts, realistic, and then the fourth one, optimistic concept. And you can see here the life cycle cost per stack for the reference concept. We can see that comparing the reference concept to the optimistic concept, drastic reduction of the price per stack is already here, but also this is very important to put into the production perspective. If we increase the production rate from, let's say, just a few from 100 stacks to 50,000 stacks, the reduction of price is very drastic. These inputs are coming from the Hansel recycling. We work together with the collection of the data, so they are realistic from the industry, and they are regarding the PEM fuel cell stack technology. Even going one step further, there on the map we can see some points. Going to the social LCA. Social LCA today means that we evaluated the whole value chain of our technology. That means that materials are collected all over the world. That means that are coming from different industries from all over the world, and with when we are producing technology in Europe, we are affecting social dimensions in all other countries. And these dots are actually showing us, in the case of fair salary indicator here, how we affect different regions where these materials are coming from in this fair salary indicator. What we can also, the last thing that I will comment in social LCA, we can see that the blue color is very much represented in the upper diagram on the right side. That means the social indicators are very effective with the platinum production. But when we go to the optimistic concept, we can see that this blue color that is marked with red squares are not so prevalent anymore. That means that when going into the eco-design, including the recycling to platinum, we are drastically lower also the social impact indicators, so that we are going toward the sustainability of the hydrogen technologies. Thank you very much.
Thank you, Mr. for this very interesting insight into the evaluation of the life cycle and also of the social life cycle of these technologies. So moving on to our last speaker of the day, I'd like to call on stage Antonio Campanale, who will be speaking mostly about the activities on the regulatory and standardization assessment. Thank you.
Thank you, Ilaria. Thank you for inviting us in this event, and also for leading this panel, and also thanks to all NV Park organization team that organized this such nice event. So good morning, everybody. I am Antonio Campanale from Rina Consulting, and I will spend very few words about my energy group, my working working group. I won't spend so many words about Trina Consulting, as Diomede, my colleague, has already gave you a clear picture of my company. And I work in the energy business unit, and we are more related with the innovation services. In particular, we work in the funded research in the innovation field and in digital. We are also growing in this field and leading some competencies and skills in this field. And in funded research, we are involved in the proposal coordination, proposal preparation, in the coordination and management of EU-funded project, and other tasks that we lead usually in EU-funded project are exploitation and communication and dissemination. The business unit where I work is the Energy Innovation Strategic Center in the same team of Alessandro. And in numbers, the R&D ongoing EU-funded projects that we are working on are 82, and in 20 of them we are the coordinator of the project, while on 62 of them we work as partner, and also in Best4I we have the same role as partner. And in the last year, in 2022, we generated 86 proposals in EU-funded project and in R&D field. In the context of Best4I, we took the lead of the regulatory assessment and standardization path for Best4I, and in particular for fuel cell technologies and for end-of-life treatments in the fuel cell field, thanks to our expertise in regulation and also as a certification body. Our approach in this task was to start from a review of all directives and standards that are trying to assess this field, and in particular we throw into the Eco Design Directive that is currently under revision, and it focuses on the aim of European Commission to have a clear picture of every energy-related products that is circulating around the market in Europe, and in particular the aim is to enable and make this product more durable, more efficient, and also to enable them to be recyclable and also to be repaired in somehow. Then we also went to the end-of-life vehicles directive that is strictly related with the fuel cell application, and it has not so clear recycling targets, and some also is missing about the fuel cell vehicles. Then we also went into the Critical Raw Materials Act because it's a very important topic, and in particular European Commission in the last years also included some new materials, some new elements that have been considered critical, like the platinum group materials, the nickel, the cobalt, that are also very important for these technologies. Then we went also to the waste shipment regulation for the transboundary shipment of wastes between the different continents. And then we also assessed the new battery EU legislation, because also in this case is a really close working field with fuel cell technologies, and also in this context there are no so clear recycling targets. And the only thing that maybe is we can try to in the future also to replicate in this context in the fuel cell technologies is that from 2027 the battery is going to be registered in order that all batteries as their manufacture, their durability, the information also for their recyclability. And but after this work of reviewing all these directives, we saw there are no directives that specifically refers to the end of life of fuel cell hydrogen technologies. And this leads to some barriers, because if there are no so clear directives on the fuel cell hydrogen end-of-life treatments, there are some barriers, it generates some barriers for deployment of these treatments, and in particular in the system design, because manufacturers need evidence of the eco-design and the proper choice of materials, because otherwise they can also they can also have negative impacts of their products. On the Eco Design Directive, market signals are not sufficient to help in disassembling the fuel cell at the end of life stage. And also in this context, producers and recyclers are not aligned. On the material selection, on the proper material selection for manufacturing, platinum-based and rare earth elements has some problems also because they can lead to increasing cost and also we know of their limited availability. And if we want to apply recycling targets coming from other sectors, from other technological sectors to the fuel cell end of life stage, maybe these targets could be too restrictive to apply in this field. So about the, we found some standards that are applicable, that are in a certain kind able to assess also the fuel cell end of life. And for the fuel cell technologies, we were referring to the IEC Technical Committee 105, and in particular it refers to all fuel cell systems for the power production to the stationary fuel systems, and also to the fuel cell for the transportation. But also here we saw that there are no such directives for the treatments at end of life stage. We saw also the recycling batteries as this normative that refers to the lithium-ion batteries and the importance to recycle lithium-ion batteries. And about the circular economy, there is this technical committee about 111, and in particular it's a standard that enables an horizontal standard for helping all the environmental aspect to assess also the safety, to assess the customer care about not only the fuel cell but all products that are circulating in the market. And so at the end of this research on the market, we try to propose new approaches for field EU regulatory assessment. In particular, we found out some primary and secondary targets. So the primary targets are to fill a regulatory gap and to adapt hydrogen technologies to the decarbonization policies. Also to detect the critical materials that are involved and to boost the circular economy, while the secondary target can be also to develop a strong and higher network between the fuel cell hydrogen manufacturers and the recycling centers. It can help also to boost the market in this way. And if some materials are recycled, also manufacturers can buy materials and components at a lower price. And as last point, also recycling centers, then they can boost their market. And so we went to this road mapping proposal. So in our after this study that we made in the context of Best4I, there are some there is still need the effort of definition of standards related to the recycling of critical raw materials, the specific roles of manufacturers and the recycling parties. And also there are no unified guidelines about performing life cycle assessment, and so if we don't have a standardized approach, it's difficult also to obtain results that are able to be compared at the same time. So the next steps that we were able to detect in the development of new standards is, first of all, to develop a standardized terminology for fuel cell hydrogens and their recycling approach. Then to look for a framework regarding the specific parts of each product, and also to enable them to be recyclable and reused at the end of life stage, and focus towards an eco-design approach. And the last point for sure is to develop real standards and to reach out the technical committees at a national level. So yeah, thanks for your attention.
Thank you very much. So this brings us to the end of the presentations for today. However, I'd like to ask a few questions to the panel. So obviously Best for I, and I'm very proud of this project, and the work that has been done in this project is quite at the forefront to develop technology, to start to identify barriers, etc. But what is actually happening in real life? And Anna, you are basically the first link in the chain for the recycling. What is your experience at the moment?
Thank you for the question, Ilaria. Well, it is an extremely new technology, so compatibly there are not a lot of end-of-life devices, with exception of test devices, materials which have proved to be defective in some way, and some waste, of course, which producers are causing themselves, because and these come in a lot of different forms, which we at the beginning of this project we didn't really imagine. So at present we are regularly receiving very few, poor streams of material. When I have to quantify it, I mean 100 to 200 kilos of gross material per month, which is extremely variable in form and content, because we have barrels with solutions and containing platinum, we have CCM film rolls, we have complete stack systems, we have partially disassembled stack systems, we have MEA packages. All of these constitute for us an excellent occasion to learn and to go deeper into the matter. Up to now we have just had one real industrial experience in disassembling the biggest electrolyzer parks in Europe, which is in Mainz, near Frankfurt, where we are based. And that was a big work, which we did together with PGM refiner, but up to now it is the only project. But OEMs are contacting us more and more often, asking to sign NDA, or in some cases even frame contracts in order to understand. One of the biggest questions is, who does the end-of-life materials belong once it is out in the market? So many of them are showing a very early sensitivity for this subject, which I welcome. I think it is good, because as far as passenger cars are concerned and other systems, the producers weren't thinking so far. So perhaps lesson learned.
Thank you, Anna. And supply chains and volumes were also mentioned by Valerie. So you mentioned the Solvay is already working on the recycling of ionomer, and yes, if you would like to tell us a bit more, and also perhaps how do you see the supply chain potentially working to get you the ionomer back for recycling?
Thank you for this very good question. Yes, I think this transition to circular economy requires collaboration of different players and in different combination comparing to standard linear economy supply chain. So it's kind of a reverse supply chain, and need to create this collaboration. And at the moment, I think we are moving in opportunistic way for certain application in easier than comparing to other. So we're building with our customer and user this type of reverse supply chain, because this requires as technology but also as logistics. So I think we're in transition and learning how to do it. And
that's important, and we'll get ready for when the volumes perhaps will start to raise. And
yes, absolutely, yes. At the end, it should be also profitable, and this generally as the industry requires certain volume as a critical mass in order to achieve this reasonable profitability level.
Thank you. Thank you. And Mitya, you showed us some very, very interesting intersections between the life cycle assessment, the social life cycle assessment, and I think the social life cycle assessment is quite a new field that we are now seeing. We are seeing requests also by the European Commission to work on this subject. Can you tell us a bit more about what's happening at European level?
Yes, social life cycle assessment now is coming into the project in the last course. So basically this is something that engineers can do because it's quantitative tool. So we are going from the same inventory and the same value chain as in LCA and LCC approach, but just including the indicators or the data from the different industry sectors in the different countries. So basically you may be heard that it's Silka database is behind that is gathering all these data. These are worldwide data of the industry sectors, and of course the indicators that are in these industry sectors in the specific countries. That means that you can somehow assess the whole value chain of your product, and of course with eco-design approach you can also relatively assess how you reduce those social impacts apart from the let's say environmental impacts when addressing eco-design. And there is a huge potential of this. But honestly, I started with LCA, so environmental part, now adding LCC, social LCA. It's really hard, and now the next step that we are challenging is how to join these three methodologies and really combine those and have indicators that would easily give us the information if some product is sustainable or not. What is actually the level to reach that? Is this just possibly to done with a relative comparison? It will be hard with the absolute measures, etc. So it is still really much field in the progression and the development, and we will have to dig really deep to get the results that will be useful for the industry. Otherwise, it's just for academia, it's not enough.
Indeed, thank you very much, Mitya. And I think that cooperation with the industry is also important to understand how a regulatory landscape could look like. So what is your take on that, Antonio?
Thank you, Laura, for your comment. And yes, about this, it's really important to have on board some fuel cell manufacturers and industry that are working in this field, especially if we want to reach the technical committees of International Standardization Organization or also the International Electrotechnical Committee that I was mentioning before. So in the context of Best4I, we were able also with the expertise of a consultancy coming from the Horizon Standardization Booster to identify two technical committees that most probably we are going to contact in the next months in the context of this project, and also maybe after for a further collaboration on this topic. And what we, as I said, it's really important to have on board fuel cell manufacturers and industry to give consistency also of our request and our willingness to try to fill this normative gap that is up to now.
Thank you. Thank you very much, Antonio. And to conclude, you are seeing on the screen the result of our last poll. So I guess as a passionate about circular economy, I can see that the eco-design and the Second Life are prominent in this cloud of words. So I guess that there is work to be done on this, and projects such as EGOS and Best4I will certainly support these areas. So this brings us to the end of the day. I'd like to thank all my panelists for the intervention today, so thank you very much. You are free to go. I hope this day has been interesting for you, and please don't forget that we have also some afternoon activities, so you will see firsthand the work that is being done by our partners, Ensel Recycling, the CEA, and Politecnico of Turin on the recycling of materials, and then with the support of Elcogen and EKPO, how these materials have then been reused into new cells for performance testing. Then there is a room available for you for doing some networking with our colleagues. But now for the closing remarks, I'd like to call on stage our director, Davide Damosso. Thank you.
Thank you, Ilaria. Thank you all for your participation, your attendance here, both as relators, as attendees to this meeting. Was for us as MV Park, these meetings are very useful in order to strengthen our network of partners in Europe and local partners in the supply chain. And it is a pleasure to me to notice that at the local level, the stakeholders on the industrial side are a little bit turning from curiosity on the hydrogen-related issues to active initiatives, investments, research and development initiatives, and so ever. And this is true for a lot of the people here in the room and possibly connected remotely. And so I think that initiatives like this are very helpful to support this roadmap. And for this reason, I kindly invite you to take advantage to be here today in order to network a little bit among each other. And so we are available to facilitate this, and we are very pleased to host you even in the afternoon, the first afternoon, to take a look to the results of the Best for Life projects, and even to the facilities that are growing in this technology park in terms of experimental initiatives for hydrogen supply chain. So we have here and in the lab building some colleagues of Environment Park as well as of Politecnico Torino and Italian Institute of Technology that are very pleased and ready to showcase a little bit what's going on in terms of specific research pathways. So thank you again for being here, and see you later.
So please join us for lunch at the entrance of this complex, and then at around 2 o'clock we will start with the session on the recycling technologies. Thank you.